Assalamualaikum and hi. I'm Rosnani Effendi from Polytechnic Melaka.
Miss Moy Fong from Polytechnic Melaka and Haji Zamali Omar from Polytechnic Merlimau.
Our project title is Monitoring, Detection and Early Warning System for Headwater at the Recreation Areas by using IoT.
And before that, did you know about what is headwater and how is it happen? Shafi et al. Mentioned that headwater is a sudden flow that is usually caused by heavy rains that occur upstream. In year 2021, for the first time, Malaysia was shocked on headwater incident at Kedah. This incident not only caused destruction to the environment but also to the property and the loss of the life of 3 residents. Meanwhile, in July 2020, once again, flood and headwater incident hit Kedah. This time, the incident has killed 3 times and destroyed several houses in the village around Gunung Binang. The estimated loss was roughly 28 million. Headwater became a common occurrence in Malaysia recently, and there are a few of headwater incidents happened since 2011. However, the effects of the previous incident are not as serious as the incident that occurred lately. Headwater has caused large scale of destruction, not only to the nature, property and even lives. In Peninsular Malaysia, there is 115 forest eco-parks, and this number is not including in Sabah and Sarawak. Thus, with the largest number of the forest eco-park in Malaysia, the headwater incident cannot be taken for granted. Therefore, a tool for monitoring, detection and early warning system for headwater incident need to be developed. The primary aim of this project is to establish an early warning system, including detection and monitoring for headwater by using IoT. Generally, there are a few systems related to early warning detection have been developed. However, the system are focusing more on flood and landslide incidents.
There are a few of previous related projects such as FANOS, Info Banjir, Landslide and Mud Flow Warning, and the latest related project is HWMS.
Headwater is usually preceded by early signs such as a sudden and rapid rise in level and velocity.
Other than that, the river water transition from clear to muddy also can be used to identify before the incident. Despite that headwater can be observed by the early signs, most of the reported incidents still result in catastrophic devastation to the infrastructure, environment, and in the death of people. The fact that the developed warning system applicability has not yet been fully evaluated, probably because of the limited understanding of the headwater circumstances. In addition, the developed systems that have capability to monitor and efficiently provide an early warning are still limited. Therefore, the developed system must have a different features and can provide an improvement to the current problem.
Methodology. Phase 1 is system development for the circuit and coding. Based on previous research, there are few of headwater signs such as water level increase, water velocity increase, and the river water change from clear to muddy. And for the proper solution, we are using 3 types of sensor, which are ultrasonic sensor to detect the water level increase, flow water sensor to detect the water velocity increase, and turbidity sensor to detect the water change from clear to muddy. And for the on-site warning system, you are using 3 alarm and 2 emergency light. For the off-site warning system, we are using Twitter notification by using ThinkSpeak. Meanwhile, for the monitoring and data generation, we are using ThinkSpeak app and MATLAB. This is the flowchart for the MDWH. Phase 2, simulation. We are using WOE for the simulation. Phase 3 is the prototype development and testing. The developed prototype. The prototype are tested by using flow channel trend. And phase 4 is analysis findings and recommendation. Result section. This is the MDWH circuit design. The system will generate both a real-time view and an immediate notification of the water level, speed, and turbidity level. In this MDWH circuit, we are using ESP32 as the development board, Arduino as the software, and then there are 3 types of input devices, which are turbidity, ultrasonic, and flow water sensor. Meanwhile, for the output devices are LED and buzzer. Then we are also using cloud technology, which are ThinkSpeak and ThinkTweet. The MDWH coding, simulation, the testing are using MDWH prototype and the flow channel. When the flow water sensor detects the water flow is more than 25 liters per minute, then the buzzer will turn on. For ultrasonic sensor, buzzer and LED will turn on if the water level is increased to 1 meter. For the turbidity sensor, buzzer and LED will turn on if the sensor detects the water NTU is increased to 25 NTU. Overall MDWH system. For the offsite warning system, the tweeter will tweet. One of the advantages of the MDWH system is the location detection notification will send to the user. This is the result of data that appear at the ThinkSpeak. Overall result for the sensor testing.
Potential collaboration for the project.
Right from my IPO.
As a conclusion, the system is successfully can generate both a real-time view and immediate notification of the water level, speed, and turbidity level. Thus, the developed system is expected to help in reducing devastation to the environment, property, and the most important aspect is to save the human life. Eventually, this project is expected to benefit the government, authorities, tourism industry owners, particularly those who operate resorts near river or recreational area and general public. So that's all of my presentation for today. Thank you and Salam Ramadan.